Math 138, Spring 2013, Test 2. Problem 8. Find the absolute maximum and absolute minimum values of function f of x is equal to 2x cubed minus 6x squared plus 4 on the interval from -1 to 1. So first find the critical values. You find the critical values by taking the derivative, which is 6x squared minus 12x of this function, and setting it equal to 0. You factor out 6x and set each factor equal to 0, so you get x equals 0, x equals 2. Now 2, x equals 2 is not in this interval from -1 to 1, so you reject it. You don't take it into consideration when you move on to actually finding the maximum and minimum values. The other part of the definition of the critical value is that's the points where the derivative is not defined. Notice that the derivative is a polynomial function, so it will always be defined. So we don't have to worry about the other part of the definition. And then you find the y-coordinates of the critical values. Well, in this case, there's only one, x equals 0, and these endpoints, so x equals -1, x equals 1. So I get the y-coordinate of 0 is 4, the y-coordinate of -1 is -4, and the y-coordinate of 1 is 0, and I find these y-coordinates here. Remember that in order to find the y-coordinate, you plug it back into the original function, not into the derivative. And the largest value is 4, which means that your absolute maximum is 4. It occurs at point x equals 0. The absolute minimum is -4. It occurs at point x equals -1. Last problem, number 9, extra credit. A boat is pulled into a dock by a rope attached to the bow of the boat and passing through the pulley on the dock that is 2 feet higher than the bow of the boat. So I made a little picture here. So this is the top of this is the dock, this is the pulley where it is. This is your rope over here. Your boat is pulled in. So if the boat is pulled in, the distance between this bow of the boat and where the dock is, the pulley really is I denoted as x. Then you know that the vertical distance over here is 2 feet, and it doesn't change because that's how high the pulley is, and the length of the rope is changing, so you pull it in so that the boat is moving this way, and z is changing, x is changing, 2 is not changing. Now the question is, if the rope is pulled in at the rate of 3 meters per second, so when dz dt is -3, negative because this distance is decreasing, how fast is the angle between the rope and the horizontal changing? The angle between the rope and the horizontal is theta. I labeled this as theta. Is here between the rope and the horizontal. How fast is it changing? At the time when the angle is pi over 6. So you have to find how fast theta is changing. So d theta dt is unknown at point when theta is equal to pi over 6. So my equation on theta is going to be sine of theta is 2 over z. Sine of theta is 2 over z. You differentiate both sides with respect to t. So the derivative of sine of theta is cosine of theta times d theta dt, so the derivative of theta, chain rule. And the derivative of 2 over z is -2, z to the -2nd power times dz dt by the chain rule. And now what do we know? We know that theta is pi over 6, that's the point. D theta dt is to be found. Z, we don't know what z is equal to when theta is equal to pi over 6. So let's find out what it is. So over here on the side I have a little triangle. So at the time when theta is pi over 6, we have to figure out what z is equal to. So sine of pi over 6 is 2 over z. I wrote it here. Sine of pi over 6 is 2 over z, but we know that sine of pi over 6 is 1/2. So you truly have 1/2 is equal to 2 over z. So z has to be equal to 2 divided by 1/2, which is 4. So the value of z is 4 at the time when the angle is pi over 6. And then you plug your values in, so you have cosine of pi over 6, the value of cosine of pi over 6 is root 3 over 2, then the value of z is 4, and the value of dz dt is negative 3. That was given to us in the problem. So you have your equation with the values plugged in over here, and you just solve this equation for d theta dt. So you simplify 2 and 16, you get 1 over 8, negative times negative gives you positive, and you multiply both sides by 2 over root 3 to get rid of this number here. So you get 3 over 4 times 1 over root 3, you rationalize the denominator, and you simplify the 3's, and you have root 3 over 4. The units are radians per second. So the angle changes at the rate of root 3 over 4 radians per second.